Hi, in this lecture video, I'll be discussing the atomic mass or the mass of an atom. Now, when we go to the periodic table to look up the mass of an element, the value that we see from the periodic table is basically the average mass of all of the isotopes of that element added together. Because we see that there's many elements that exist as multiple isotopes. And those multiple isotopes have different percentage of abundance to them at all. So overall, what would be the average mass of an atom given all of these different isotopes? So that's what the atomic mass or the average atomic mass is. So the atomic mass of an element is a weighted average of the mass of the different isotopes, and it's been calculated as follows. So the average atomic mass equal to first the percentage of abundance of the first isotope multiplied by the mass of that isotope plus the percentage of the abundance of the second isotope multiplied by the mass of the second isotope and multiplied by the third percentage of abundance of the third isotope multiplied by the mass of that third isotope, and so on. And that's how we can calculate the weighted average of the different isotopes. Let's now try an example. Gallium has two naturally occurring isotopes. Gallium-69 with a mass of 68.8256 AMU and a natural abundance of 60.11%. So that's one isotope. And the other isotope of gallium is gallium-71 with a mass of 70.9 AMU and this natural abundance right here of 39.89%. So here in this case, we call this gallium-71 because if we were to round this value right here to the one place, it becomes 71. So calculate what would be the atomic mass of gallium. And whenever we refer to the atomic mass of an element, of course, we are referring to the average atomic mass. So we have to take into consideration of this different isotope right here. So in this case, the average atomic mass of gallium would then equal to first the percentage of the first isotope. And in this case, it is 60.11%. And we have to convert this into a decimal number, which equal to 0.6011 multiplied by the mass of this, which is 68.9256 AMU, plus the percentage of the second isotope, and we have to convert this into a number. So in this case, 39.89% will become 0.3989 multiplied by the mass of the second isotope, which is 70.9247 AMU. So adding this together, this would then equal to 69.72 AMU. And when we go to the periodic table, we would then see that this is the value being listed on the periodic table. Please try this following example at home.